Hey PhysCalc, welcome to another video in the PhysCalc Maverick series. So for this video, we're going to be walking through an example of the product rule. Now remember, the product rule is what I do in order to take the derivative of two functions that have been multiplied together. So let's say I want to do d over dx of f of x times g of x, where f and g are functions. So when I'm multiplying two things together and trying to take a derivative, I have to use the product rule. Now, what I'm going to be doing in this video is walking through an example that uses two functions multiplied together where one of those functions is a fraction. So we're going to be starting with a function that looks not like a product, but like a quotient, like a division function. But we'll see that we can basically do the same thing. Because division is the inverse of multiplication, I can use the product rule on things that are divided as long as I rewrite them in a way that makes sense. So what I mean by that, let's look at our example here. Let's say I want to take the derivative of the function x squared plus 7 divided by x cubed. Now you might be saying, Alex, it's such a complicated function. It's a quotient. It's not a product at all. And there is a quotient rule in derivatives. If you guys look at the online Paul's Math Notes resource that I linked in the homework, they actually use the real actual quotient rule. And that's how I learned derivatives when I was in high school. But it's much easier and much more intuitive to just turn this function into something I can use the product rule on. So we're going to do that first. So let's do some work up front to make our lives easier in the long run. That's like kind of what calculus is, right? So d over dx, and I'm going to keep my x squared plus 7. My numerator is just going to chill, but my denominator, x cubed, is going to become something else because I can rewrite divide by x cubed as multiply by 1 over x cubed. Because remember, multiplication is just the inverse of division. Now one more step to make this even easier. I've still got my x squared plus 7, but when I have 1 over x cubed, I can rewrite that as x to the negative third. So this is my new function here, which has been sort of gussied up a little bit to look like something that's a nice, easy product rule, because this is now two functions very clearly multiplied together. Now the product rule tells us that when I'm taking the derivative of this, it's equal to the first function times the derivative of the second plus the second function times the derivative of the first. So when I solve the product rule, I need both the function and its derivative, and the function and its derivative, or vice versa. Which means that I both need to identify f and g, and then I need to take their derivatives. So let's do that now. Let's identify my f of x, and let's identify my g of x. And I get to pick which is which, so I'll just pick my first function that I'm multiplying by, my x squared plus 7, and make that my f of x. So x squared plus 7. For my g of x, I just take the thing I'm multiplying it by, x to the minus 3, and I'm done. F and g have been identified. Now I need to find the derivative of both of them, f prime of x and g prime of x. F prime of x is pretty easy. It's just going to be 2x plus 0, or 2x. G prime of x, a little bit trickier, but thinking back to our power rule, we're just going to get negative 3, x to the negative 4. All right, now I've got my pieces. The last step is to put them together. So this is going to be equal to f of x times g prime of x plus normal g of x times f prime of x. So all of my pieces fall into place there. So now that that's done, all I have to do is simplify my answer. So now I've got all the stuff added and multiplied, so let's just simplify it all out. So first things first, I'm going to distribute my minus 3x to the minus 4 in here, and I'll get minus 3x to the minus 4, x squared, minus 21x to the negative 4, just by distributing that. So that's kind of my first term here, plus 2x, x to the minus 3, and that's just by multiplying these guys together. So let's do some simplification. Remember, this is x to the 1. So negative 3, when we multiply 2x to some powers together, we add those exponents. We get minus 3, x to the negative 2, minus 21x to the minus 4th, plus, same thing here, we'll add these together, 2x to the minus 2. You can see here we've got these two like terms, so we're just going to go ahead and add those guys together. Minus negative 3 plus 2 is negative 1, x to the minus 2, and we get minus 21x to the negative 4th. We're just going to clean this up a little bit for our final answer, and we'll find that this is negative 21 over x to the 4th, that's just this term right here, minus 1 over x squared for this term here. And that, y'all, is my final answer. This is the derivative of x squared plus 7 over x cubed. And we're done.